Well, in this video, we are going to actually start using Pythagoras' theorem. We've been exploring some of the theory behind it, but now we're actually going to start to use it to do some maths to calculate unknown lengths for hypotenuse in a right angled triangle. Now, you might remember that the formal way of writing Pythagoras' theorem is this: c squared equals a squared plus b squared, and we looked at that when we did our 3, 4, 5 triangle video. However, I want you to put that aside for a second. I want you to forget that for the moment, because when we're actually using it, I have a preferred way of doing it, and I'm going to show you and explain why as we do it. Here's our right angled triangle. We've got a length for this side and a length for this side, but we don't have a length for this side. This is our hypotenuse. It's the longest side of a right angled triangle. It's also the one that's opposite the right angle. Now we are going to calculate the actual length of this side. Here is the formula I'd like you to use and learn. And the reason I want you to learn this, because we can use this or a slight variation of it for any of these kinds of questions, whether we're finding the long sides or the short sides. I also don't like the ABCs, because what happens if you've got a triangle and it's got X, Y's and Z's in it? And it just gets confusing. Learn this, you'll be able to apply it, and hopefully it will make sense to you. In this case, the length of our hypotenuse is simply the square root, and inside the square root we put the length of one side squared plus the other side squared. So let's have a look at how that looks in numbers. The length of our hypotenuse is the square root of this side, which was 3, so I do 3 squared, plus the other side squared, so 4 squared. Okay, so they're my two lengths, 3 and 4. I put them in here, I square them all inside a square root. I can put that straight into my calculator, or you can do it in two pieces. I can see that 3 squared is 9, 4 squared is 16. But it's quite acceptable just to put that, if you want, straight into your calculator in one piece like that, and you'll get an answer that comes out as 5. So that means the length of this side, my hypotenuse, is 5 centimeters. Done. We've used Pythagoras to calculate the length of the hypotenuse. Let's do one more example, this time with a few some decimal values, but the maths is exactly the same. The process is exactly the same, even though the numbers look a little bit uglier. We've got a right angle triangle because I've got my right angle symbol. This is my hypotenuse. It's the longest side opposite the right angle. So I'm going to use that same formula. The length of this hypotenuse is simply the square root of one side squared plus the other side squared. And here are my two sides, 6.2 and 2.8. So I'm going to put them in. It doesn't matter which one I do first, because you can add things in any order. That's not a problem. And I can put that now into my calculator, and I'll get a value of 6.8. So the length of this hypotenuse is 6.8 millimeters. That's it. You guys are awesome now, because now you can use Pythagoras' theorem to work out the length of a hypotenuse in a right angled triangle. Well done.